Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelia Subinda with another video. Now in this video we're doing 2023 Paper 1 Internal ECZ Additional Mathematics Vectors question. Now in this video in 2023 it was question number 11. So it changed from question number 10 to question number 11. Let's get on with the question and follow. The position vectors of points P and Q relative to the origin O are 4i plus 2j and ki plus 4j respectively. Find, given that QP is perpendicular to OP, find the value of k. And then we have our question 2 there. So in total, just know that vectors always carry 9 marks, which is 4 marks here, 5 marks here. It varies. It's not always constant that here you have 4 marks. Sometimes it may be 3 marks here, and then 6 marks here. But in this case, in this year, it was 4 marks there, 5 marks there. So to continue, before we even go any further, we need to take note of certain things, certain statements, like given that QP is perpendicular to OP. Under vectors, if we say vectors are perpendicular, it means that their dot product is 0. Q dot P is equal to 0. Why is it that their dot product or their scalar product is 0? Because if you think about a cosine wave is in this particular form, okay? And then here, this is where it starts from, of course. Right about, let me say, it starts from there and then it continues like that, okay? So this is your basic x or y plane. Let's do it like that. Now here, when it crosses, it is 90 degrees. There it's back to 180 degrees. And then here, 270 degrees. Here it is 360 degrees right there on top. So like that. Then there is 0. So the number there is 1. At the lowest point, which is somewhere there, it is -1. Then there it's back to 1. What am I trying to say? Cos 90, using this wave, the cosine wave, it is 0 because it is going right there. This line is 0. Here, where these two lines intersect, the x-axis and the y-axis, it is 0 right there. So because here, cos 90 is 0, the dot product is also 0. Alright, let's get on with the question. What do I mean the dot product is 0? The dot product, for example, is A dot B. Vector A dot B is equal to magnitude of vector A multiplied by magnitude of vector B multiplied by cosine theta. So without even substituting anything here, I'm just going to continue. Is equal to, maybe for the magnitude of vector A, you have a certain value, for vector B, certain value, but here they are at 90. Perpendicular means 90 degrees, like that. So A dot B would be equal to magnitude of vector A multiplied by magnitude of vector B multiplied by cos 90 is 0. So everything here will be 0. It means that A dot B is equal to 0. So this is just the proof of what I'm talking about. So it means that A dot B will be 0. So let's get on with the question. Let's write the position vectors. They said respectively. So OP is equal to the first one, which is 4i plus 2j, and then we have the next one is OQ, which is equal to ki plus 4j, ki plus 4j, like that. And then they're saying that the ones that are perpendicular are QP and OP. So let's find QP. QP would be equal to QO. So when you're doing this, finding this vector here is called the resultant vector. Always make sure that the vector is this side. When you have vectors having O here, you can see that even here they also have O. So I've done the opposite of this one here. QO plus OP. It's not always that you have to write it in this form. So it's QO plus OP, just like that. QO would be minus KI minus 4J. So what have I done? To find the opposite of OQ, you just, everything that is positive becomes negative. So all the signs here are positive, so they are now negative. Alright. And everything that was negative becomes positive, but nothing was negative here. There are only positive signs, so we carry on. Then we have 4i plus 2j. Then we group the like terms together. Negative ki plus 4i minus 4j plus 2j, like that. Here, we factor out vector I here. It will be equal to minus k plus 4 of vector I. Here it will be minus 2j. And this is our QP. That's our QP, just like that. And then we also have our OP. OP is equal to 4i plus 2j. So even if it's here, I've written it here so that you can just look at the two vectors. And then we just proceed with the answering. We are saying that this and this are perpendicular. So their dot products should be equal to 0. Right? What am I saying? I'm saying that, let's write it like this. Minus k plus a 4i minus 2j, like this. Let's put them in brackets because there's already a parenthesis here, or a bracket. Dot OP, which is 4i plus 2j, is equal to 0. So this kind of now looks, confusing. Interesting now. How do we proceed? What I said, I squared is 1, j squared is 1, I times j is equal to 0. So let's take that in mind, into consideration. So we're just going to multiply negative 4 and negative k plus 4 multiplied by 4. So it will be 4 multiplied by negative k plus 4, like that, negative k plus 4, and then negative 2 multiplied by positive 2, which is negative 4, and this should be equal to 0. So I've just gotten everything having I here is negative k plus 4, everything having I here is 4, we multiply, and then everything having j here is negative 2, here it is positive 2, so I multiply them and I have that negative 4. And then here we just expand this bracket, we distribute the 4 in this bracket, it will be negative 4k plus 16. 4 times 4 is 16, minus 4 is equal to 0. At this particular point, we can just take the 4k to the other side. 16 minus 4 is 12, is equal to 4k. We divide by 4, we divide by 4. 4 can go into itself 1, 4 can go into itself 1, 4 can go into itself 1, into 12 is 3. Therefore, k is equal to 3. So that's your answer for A. Your k would be equal to 3. So we are done with that. K is equal to 3 for your question A. Then we go to B. Two lines R1 and R2 intersect at R. R1 passes through the points with position vectors that and that. Given that R2 has this vector equation, right? So R2 has this vector equation, that's what I'm trying to say. And then they're saying R1 has these two position vectors. It passes through these two position vectors. They want us to find the coordinates of R. They're saying they intersect at R. What do we do? In this case, we need to form two scalar equations. Now there's the method 1, where you can use lambda. So lambda is the same as t. Okay, it is used like a parameter, like the parameter t. It is used like the parameter t. It's not a parameter, but it's used like the parameter t. That is our lambda there. Don't get confused. It's just that the same thing that t does. Okay? We have our lambda there. What am I trying to say? That we don't need to write R1 in this form, because that would be a waste of time. The only thing that we need to do is use these two position vectors. Because they have told us that they are position vectors, it means that those two are coordinates. We would find the equation of a line, and then we write it in the scalar equation form. It means we have found the scalar equation. And then here, this one having lambda, the I plus a 2j right there, that's a direction vector. What we're going to do is we're going to find the normal vector and use the properties of the normal vector to find the scalar equation. We'll solve them simultaneously. Where they meet, the answer that we're going to have is where they meet. Right? Hope that's clear. Okay, let's start with R1. We have the position vectors 5i plus 3j, and we also have minus 2i minus 4j. Let's write this in the form of coordinates. This will be 5, 3, and then negative 2, negative 4, like that. Okay, so I will name this as my x2, y2, x1, y1. You can use any order, you find the same answer. And then I'll go directly, y minus y1. So this is the formula for finding the equation of a line, is equal to y2 minus y1 over x2 minus x1, x minus x1. It's just simply saying y minus y1 is equal to mx minus x1. But instead of putting this m, I've substituted the formula for the gradient. I've done this so that we cannot spend more time than already we have spent. Alright. So y minus y1, let's continue. Y minus your y1 is your negative 4 is equal to your y2, which is your positive 3, minus your y1, which is a negative 4. So anything that is negative, make sure to put them in parentheses. Negative 4, like that. So 3 minus negative 4, like that. And then here you have your x2, which is a 5, minus your x1, which is a negative 2, also in parentheses. And then we have, you multiply by x minus, our x1 is a negative 2, put it in parentheses like that. Okay. Y plus 4 is equal to 3 plus, 3 plus 4, you divide by 5 plus 2, x plus 2. Y plus 4 is equal to 7 divided by 7, x plus 2. 7 divided by 7 will simply be 1. So y plus 4 is equal to x plus 2. Because this 7 into itself is 1, 7 into itself is 1. And then let's write this in the form of a... Okay, let's just write it in the basic form for an equation that we want to solve simultaneously. So it means we're going to have our positive x, and then this y will go this side, minus y is equal to 4 minus 2, positive 2, and this will be our equation 1. So x minus y is equal to 2 as our equation 1. Equation 2. Let's get on to find equation 2. So our equation 2 would be what? We have our R2. Let me just write our R2 is equal to I minus 3j plus lambda multiplied by I plus 2j. This, having lambda here, is a direction vector, so m is equal to 1, 2, and then our normal vector, which is n, would just be equal to, I flip it, so I've just interchanged the 2 has gone up, the 1 has come down, like that, and then I make any of the numbers negative. Usually I like to make the top number negative when both of them are positive, like that. So let me make the one negative. Negative. Like that. We'll still get the same answer. So why am I doing all this? Finding normal vector, all that kind of stuff? Because of this property. Normal vector n is equal to a, b. The scalar equation form is ax plus by plus c is equal to 0. So these coefficients of the constant x, coefficient of the constant y, they are the same as normal vector. So knowing this, we're just going to say 2x minus y, because it's negative 1, we don't write 1, so minus y plus c, okay, plus c is equal to 0. Simple. And then we have this here, I minus 3j. This represents a position vector. So in this equation, we substitute the position vector, which will be 2 multiplied by 1 minus negative 3, like that. In place of the y plus c is equal to 0. This would be 2 plus 3 plus c is equal to 0. 5 plus c is equal to 0. C is equal to negative 5. Simple. And then this is our equation there. So in place of c, we're putting negative 5. 2x, not changing anything. 2x minus y. Then we'll say minus 5 is equal to 0 as our equation. That would be our equation 2. So we have our equation 1 and our equation 2. Simple. We can proceed. I don't know if you want to solve them simultaneously. Yeah, I mean, I don't know if you want to solve them by elimination or substitution. So we have 2x minus y is equal to positive 5. I've taken the 5 the other side, and then x minus y is equal to positive 2. In this particular case, I'm just simply going to add them. Alright? I'm just going to add. Subtract, because they have a negative sign. So I'm going to subtract there. Then it will be 2x minus x, which is just x. Negative y minus positive y will give us 0. So we have eliminated y. 5 minus 2 is 3. So say let x be equal to 3. We have x minus y is equal to 2. And then 3 minus y is equal to 2. We take the y the other side. 3 minus 2 is equal to y. Y is equal to 1. So in concluding, you need to write a statement. So the point of intersection is 3, 1. This is your final answer. But in concluding, you say, therefore, alright, therefore, okay, you don't need to write a statement in this case, because you are taught to find the point R, coordinates of the point R, which is 3, 1. So just say therefore R is 3, 1. No need to write a statement. But if they said the point of intersection, just right there, the point of intersection is 3, 1. Now here we just say therefore R is 3, 1. This marks the end of this video. If you stayed until the end of this video, I thank you so much. This video will really help you, and I really thank you for the support being given to me. And I thank you for following, and I thank you for your comments. And I hope you can comment more. And I just hope until the future, this has been Cornelius with another video, and bye bye.